Yeah, sorry for the delay. And now, up to last class, we have seen about the amplitude modulation and different types of techniques. Now, today we will see about the frequency modulation. So, this frequency modulation we can derive from angle modulation. So, ANGLE. So, last class we have explained something about this, but due to some technical problem, the class was cancelled. So, again I am going for this angle modulation. So, we can see that AC carrier waveform AC cos 2 pi FCT plus phi. Okay. So, in this cos 2 pi FCT plus phi, so this is nothing but a frequency and this is an angle. Okay. So, with this I can get a frequency modulation, with this I can get a phase modulation. So, total this I can say AC cos theta of t. So, this is nothing but AC cos theta of t. So, simply I can call this as theta of t is angle. So, I can say that this is an angle modulation. So, this angle modulation are we can derive two ways: frequency modulation and phase modulation. Okay. So, in this now we will see first about this frequency modulation. What happened? What is meant by a frequency modulation? So, the frequency of the carrier is varied according to the message signal. So, that is nothing but a frequency modulation. The frequency of the carrier waveform. The frequency of the carrier waveform is varied in accordance with the message signal frequency. So, this is nothing but a frequency modulation. In this, one thing is important: the amplitude doesn't vary, it will never vary. So, amplitude is constant in this frequency modulation. So, here AM if you consider and FM you consider. So, AM before modulation, the amplitude of the carrier frequency is before modulation. Amplitude of the carrier frequency is AC, and after modulation it will get it AC into 1 plus Ka m of t. Okay, this is after modulation. So, here you will get before modulation Fc, and after modulation you will get Fi is equal to Fc plus Kf into Fm, or I can say Kf into m of t. Now, as of now we will see about m of t only. Okay. So, what it will happen now, if m of t is equal to 0, this will become Fi is equal to Fc. If m of t is equal to 0, Fi is equal to Fc. Okay. This is the thing. Now, next what we will get, it means Fc, Kf is nothing but frequency sensitivity factor. Like amplitude sensitivity factor Ka, this is Kf, frequency sensitivity. So, this I can say in hertz per volt. Okay, this is the units of this Kf, frequency hertz per volt. Okay. So, now this Kf indicates what is the frequency change per 1 volt change. How much is the frequency is going to be changing for a 1 volt change. So, this is the basic thing of this Kf. And now, if you take one frequency modulator, this is message signal m of t, this I am getting Fi. So, you know Fi is equal to Fc plus Kf m of t. Okay. So, let us consider Kf is equal to 5 kilohertz per volt. Okay, 5 kilohertz per volt. Now, if m of t is equal to 0, what it will become? Fi is equal to Fc. If m of t is equal to 2 volts, what it will become? Fi is equal to Fc plus How much is this one? 2 into 5, 10 kilohertz. Now m of t, if m of t is equal to 5 volts, so what you will get at Fi is equal to Fc plus 5 into 5, 25 kilohertz. Like this, if the input frequency, if the input voltage is varying, the output frequency is varying. So this we can also call as voltage to frequency converter. FM, frequency modulation, is also called as voltage to frequency converter. Voltage to frequency converter. Why? Because so here we are applying the frequency for frequency modulation. Input we are applying as a voltage, and the output corresponding to this voltage, this is varying. Output frequency is varying. So this is called voltage to frequency converter. We can call it as, okay. And now